Hello, welcome to EC260 Labs. This video, the first of a series of videos I'm going to be producing for you, I'm going to show you how to do the schematic capture of your Lab 1 manual. So let's get started. The first thing we need is a power supply. So in the lab we have a power supply that is 3-phase. We don't have that in PSIM. We have two options to construct our power supply. We could use waveform signal sinusoidal generators, individual ones. We can wire them up, and the only thing we need to do is to put them in 120 degrees apart. But because we're using 3-phase in a Y connection, there is a convenient voltage source for that. So if we come to the source library and we get voltage, we will see the 3-phase sinusoidal. So let me put this one in the circuit, and I like to rotate this one so it looks like this, and if I put it in this position here, it's much better for me to wire up the rest of the circuit. The second component we're going to be using is the resistors. This one you can get from the speed bar here. So let me grab the resistor. I'm gonna put this quite far so I have more space to put all the cables and instruments here. So let's put this in one here, this one about here, and this one about here. So now we have the 3 resistors, and we need to add all the instruments. For instruments we have different options. We of course can use some from the speed bar, but if we go to the other library and we get probes, we have different probes. Here we have all the probes that we probably need. For this lab in particular, we can focus on the current probe or the voltage probe. These are waveform like probes, similar to oscilloscope output. Then we have the DC voltmeter and DC ammeter. These ones are not very useful for this lab because we're going to be using these AC signals, but the AC kind are very useful for us. So what is the difference between these two? Well, the difference is that these ones measure effective voltage or current in the circuit, and is different to a waveform. This will give you a fixed number if the current or voltage does not change in amplitude, whereas this one will just show you the waveform. So let's use this one for voltage. So the voltage, the voltmeters needs to be in parallel with the resistors, because that's the voltage we want to measure, and the current needs to go in series with the resistor because we need to measure the phase current. And we need another one of these in here to measure the line current. Likewise, we need an AC meter to measure line voltage. In addition to this, we need to use current probes and voltage probes so we can see the waveforms in an oscilloscope like window. So let me put this in here. So for this case in particular, for the ammeter, you have two different options. You can connect an ammeter in parallel with another ammeter, or you can connect them in series with another ammeter. And the reason you can get away with this particular configuration for ammeters is because they have a very small input impedance. So the internal resistance of this instrument needs to be almost 0, and if you connect 2 0 resistance in parallel, the resultant is even smaller. And if you connect them in series, if they are very close to 0 and the signals we're using are very large compared to the voltage drop in these values, they are not going to have a huge impact on your system. So now we have all the instruments. Let's see if that is correct. No, I'm missing the voltage probes. So the voltage probes needs to go in parallel with your voltmeters. And now we can do the wire up. So let's do that. we can connect them, all of them. Remember, this is the common node, so we can basically connect everything directly like this way. And that is what will basically finish up our circuitry. So this goes here, this goes here, and so on. Once we finish the circuit, what we need to do is to name everything properly, so all the components in this circuit are properly identified. That will actually help us run our simulations quicker and without making mistakes. Mistakes do happen, so whenever you finish the circuit, make sure you check out everything. So now I'm going to start naming the resistors. So for this is going to be R1, the value is going to be 200 ohms for resistors and oil components like this in particular. I like to show their name and show their value, name or reference. So this is R3, 200 ohms. So we check that out. Let us check the voltage source. So this is a 110 RMS. This is the value we use in Canada, and the frequency is 60 Hertz. So there's no change to be made to this one. Now we need to name all the instruments in the system. So for the AC meters, I am going to use the same names in the circuit. So for example, this is the first phase, so I'm going to use E1. This is going to be E2, E3. This is going to be E4. This is going to be I1, I2, I3, I4. Now, what names to use for the waveform, voltage, and current meters? Well, in this case, I will basically use the same convention, adding just a W in between the first letter and the number, and that way I know this is the same as the AC but in waveform. So for example, this one will be named
AW1 and AW2 and so on. EW3,
and there is one missing there. I'm gonna add it. So I need a voltmeter here. Let me just rotate this one.
and this is going to be EW4. Now I need to name the ammeters, so this is IW1, IW2.
You can also choose to show the names of these components, but that can create a lot of clutter. So if you name them properly, you will know where they are. So let's check out. So this is E1, EW1, E2, EW2, 3 and 3, and this is I1, I1, I2, I2. So everything seems to match. That's the end of the wiring process. Let's save this one. I'm going to save this in lab 1 schematic 1. Saved. Now we can quickly go into the simulation. So if I after saving, I can simulate, and what is going to happen is that this scene view window is going to show up, and if we double click here, we can add different instruments or remove them. So let's remove them all, and let me add the AC voltmeters for the phases and see what happens. So now we see that the voltage is 0. That's weird. because it shouldn't be like 0, right? So the source is 110 volts. Something weird is happening. So what's happening is that we're missing here from the simulation control block, and this allows us to simulate beyond 10 milliseconds. And now if I put here 250 milliseconds and I simulate this circuit again, now we have a different view. And look what happened. So what happens is that the AC instruments, the AC voltmeters and ammeters, they need time to get to the stationary condition where they can show you the value with confidence. So you need to add more time to the simulation. And if that happens to you, it is not that the instrument is not working properly, or maybe it's not the circuit, is the simulation time. So keep that in mind. For all your circuits, you need to add more simulation time in most cases. Now if we remove these sources and we use a different curve, like if I use the different phases in waveform, this is what shows up, and this is a very familiar picture for you, so you should be already familiar with this one. This is the usual three-phase signal waveform for a three-phase generator. This is the end of this video. In the next one, I'm going to show you how to use SimView to do measurements and how to get the best of it, because we're going to use this for different calculations, like for obtaining RMS and power factor. And in a video after that, I'm going to show you how to use SimView and a different circuit configuration to be able to produce the phasor plots.